Okay, today we're going to be talking about the characteristics of quadratic functions. So please give your paper a heading. Write the characteristics of quadratic functions. And then before we section off our paper, we are going to start off with our essential question. So please copy down our essential question. What are some of the characteristics of a quadratic function of the form of f of x equals ax squared? We will be looking at functions in this form. F of x, that's just another way of writing y, equals ax squared. A is going to be a number, any number other than 0, even fractions, and we'll look at that as we go along. So now please go ahead and section off your paper, draw your line down the side, and we're going to start off with our first definition. First definition is the quadratic function. It's a nonlinear function that can be written in the form of y equals ax squared plus bx plus c. And all this takes place where a does not equal 0. Quadratic functions have a unique characteristic in which they take the shape of a U. A parabola is the U shape of a quadratic. I'm pretty sure you've seen these before in previous math classes. Let's talk about the characteristics of a quadratic function. The parent quadratic is f of x equals x squared. We're going to be looking at this when we're typing in the decimals. This is the one that we're going to be comparing everything to. So f of x equals x squared. This is our parent quadratic. From here, we build upon it. We're going to be adding, subtracting, putting numbers in front. We're doing all kinds of things that'll be moving this parent function all around the graph. Our next definition is the vertex. It is the lowest point on a parabola that opens up, or the highest point on a parabola that opens down. When we have the U shape, if it's facing up, it is the lowest point. If it's facing down, it is the highest point. Our next definition is the axis of symmetry. It is the vertical line that divides the parabola into two symmetric parts. Let's look at a drawing of all this. So what I want for you to do on your paper is to sketch your x and your y axes, draw your u, and let's talk about what the quadratic function, the characteristics of it are. Here is the lowest point where it changes direction, and that is called our vertex. And going through the vertex, cutting the parabola in half, is our axis of symmetry. On the left side, we are decreasing until we get to our vertex, and then we start increasing. Let's look at some examples. Now, every now and then you're going to have to pause as you're taking notes in order to write everything down. That's fine, or you're going to have to rewind. Please do so. So on your paper, I want you to give it the heading still. If you had to go to a new page, the quadratic functions continue. I want you to sketch this. Now, I know it looks like a lot, but all we're going to do is put our x-axis, our y-axis, and we're going to put our parabola going 2 spaces below our x-axis. And then I want you to write down that the function is decreasing on this side, the function is increasing. Our vertex is -1, -2. And our axis of symmetry goes through our vertex, and all we have to look at is our x part of our vertex, and so our axis of symmetry is x equals -1. It goes right through the x part of our vertex. Let's look at a second example. Please once again sketch your x-axis and your y-axis. Number 1, -2, 2, your -2. Sketch your graph going from 2, -3 up, 2, -3 up. And we're trying to find our vertex. And our vertex is our lowest point right here. So that gives us 2, -3. I told you previously, in order to find the axis of symmetry, all we have to do is look at our x part. Just look at our x part, and so our axis of symmetry is simply x equals 2. One last example is gone. Oh, I only want to do 2 examples. So here we go. I want you to try to find the vertex and the axis of symmetry on our practice problems. Please now on the bottom of your page, write your summary, and then come up and get today's assignment.